Hello, good afternoon. My name is Aaron Lessing. I'm with Apex. I'm the VP of Business Development. I've been with Apex North America since we opened our doors in early 2000. I started off in '88 with our friends from Pomarco. That's how I got my start. So flash forward to today. We have a lot of nice things happening here with Apex. We've got 5 manufacturing plants globally. Over in Europe, we specialize specifically in the corrugated market. We deal with all of the major OEMs. And now here in the U.S. in the last 7 or 8 years, we've shifted our focus to corrugated as well. And it's helped us tremendously with our roots from Europe. So now we have the privilege of supporting a couple of the largest integrated companies here in North America. Really what separates Apex from the pack is I'm very proud to say that everything we do is back to OEM specifications. In other words, when we receive either an analox roll or a glue set, the first thing we'll do is we'll pull an original OEM drawing. We'll put it right up against the analox or the glue set. We'll take a look at, from soup to nuts, from drive side to operator side, bearing surfaces, keyways, threadings, TIR, that's the concentricity, diameters, straightness. We're going to make sure that those specifications are done exactly back to OEM specifications before we even talk about resurfacing the analox. In our minds, what good is having a perfect surface on your analox roll if you don't have a good bearing surface, if you can't load it in there properly? So once we do that, the roll is now ready for resurfacing. So for an analox roll, we're going to strip off the old ceramic. We're going to strip off the old corrosion barrier. We're going to put a brand new stainless steel nickel corrosion barrier beneath the ceramic, which is critical for the water-based inks. The last thing we want is a hard phone call saying your rolls are bubbling up or corroding. So we can essentially guarantee that you'll never have any corrosion. We'll then plasma spray one of the hardest, most durable, most least porous, most consistent ceramics to the surface of that roll. We'll then have a proprietary way of finishing and honing that so that we maintain a maximum TIR of 0.0005, which our goal is to meet or exceed the OEM specification as far as dimensions. Once we finish the roll, we're now ready for laser engraving. We have a variety of different typical engravings that are used in corrugated. Probably the most general one that we all offer is a 60-degree hex. It's a 6-sided cell. Or we have the elongated, we call it long cell. This is very nice for overall coverage, not as good for tight reverses or fine type. And then finally we have our Apex specific GTT. It's a patented engraving. It looks like a 2-sided solemn channel. And this particular engraving,
you can show me something.
This gives you the best of both worlds. I just want to make sure that you see this, that this was done with one printing station. This was not done with 2 or 3 stations. Most folks, when they look at that, they say, hey, that had to have been done with a couple of different downs. No, this was done with one.
Wow.
So this particular sample is a B flute with a typical GCMI type ink. And what I like to show is you've got a big solid here.
Wow.
But in addition to that solid, you've got some type, both positive and negative, barcodes, QR codes, positive and negative lines, screens going from solid fading down to nothing. This is essentially mission impossible with a conventional analox roll on one down. So this technology has really helped put our name on the map. The other additional benefit to this is that it helps us with the cleanup ability. It's another big problem in the corrugated world is how do we keep these darn rolls clean? So now we've got a river versus a pothole. Basically, where's one of our, oh, here we go. Sorry.
Oh, it's good.
I'm not ready. Here we go. So here's what it looks like is this 2-sided river versus a 6-sided cup. So essentially, this river is roughly 30 to 40% shallower to get the same density. So it releases better. So as a result, it allows us to go to a much finer line screen. So by going to a finer line screen, that's going to help with the resolution. So we've got the releasability for the density and the resolution for the clarity. So really, if you just want to boil it down, essentially what we made was a roller that should be easier to keep clean, which widens the range of graphics that you can typically print with. and we've had a lot of positive success with basically all of the OEMs with this particular type of engraving. So that's basically it as far as the engraving. I don't know if you want to talk about glue sets, but that's our other huge area of.
If you have something to talk, that I have only one word: sustainability. If you know this word, you can tell something about sustainability.
Okay, so in other words, longevity and durability. Okay, so this is an entirely different topic. Is the other types of rolls that we manufacture is a huge part of our business is the glue roll and the metering roll. These are the rolls that deliver the controlled amount of starch to make the board. And what's critical with these types of rolls is that you have a very controlled gap, so you don't put too much, you don't put too little, so we can help make better board, less warp, less washboarding, better printable, less rejection, and also with the possibility of saving starch, which is very costly today, as well as saving energy because we're now putting a thinner, more uniform layer down. We can help by turning the boiler down, which means less energy costs. So essentially what we're doing with these, with the applicator roll, just to start with the applicator roll, is the traditional applicator roll is made out of a chrome surface. It's mechanically knurled and chrome plated. Typically the demise of this roll is over time, the chrome will flake, it will possibly corrode. It's easy to get plugged up. The chrome has some porosity to it, which is shiny as it looks. It wants to grab hold of that starch, so they're a little bit difficult to keep clean. And not only that, is the chrome is relatively thin. It's only about not even a thousandth thick, about a half to 7/10 thick. So it's very easy to damage. So when we take an applicator roll and convert it, what we'll do is we'll take that roll, we'll turn it down approximately 100 thousandths per side. Okay, this is a great example right here. We'll turn the roll 100 thousandths per side. We're then going to arc weld stainless steel material to the core. We're then going to grind, turn, and hone to a maximum TIR of 0.0005. That's a half a thousandths. That's on both the concentricity and the diameter. We want that roll to be as round and straight as humanly possible to make. And that's critical to help control the gaps. Once we have the roll as round and straight as we possibly can do, is we'll use a brand new virgin mill to engrave or knurl the pattern. Typically it's a 25 quad on a double backer, could be up to a 35 quad on a single face. But 25 to 35 is typically what's recommended. We make our own mills, excuse me, and it's important that we use a brand new mill because when we're engraving, we're applying virtually tons of pressure and we're actually wearing that mill as we go. So the last thing we want to do is reuse that mill. So we'll actually send that back and have it refurbished. But the whole idea is we want to make as consistent engraving from drive side to operator side as we possibly can. Once we're done with this, the roll goes through a proprietary finishing process. We don't want to have any rough edges. Maybe if you rub your finger on a typical chrome roll, it feels a little bit rough. If you rub your finger on this, you'll notice it's extremely smooth. So again, this helps with the releasability of the roller. So the selling point of this particular roll is because of the fact that it's stainless steel, you never have to worry about corrosion. Number two, because there's no chrome, there's no chance of flaking. These are two of the major reasons that we see these rolls, the demise of a glue set. Number three is as we engrave this thing, we're actually hardening the stainless by all the tons of pressure, so we make it more durable. So it's a much harder, more resilient surface than the chrome. Now, so the selling point is that this surface should outlast a typical chrome roll by 2 to 3 times. Now, some of the other reasons that these rolls die prematurely is they crash into the applicator roll. What we do, for example, with BHS and now with Marquip and now with Langston, is we add what we call a crash ring on the very edge, where it's only about 2 to 3 thousandths above, and it's only in the last inch on each side. And if that roll happens to crash into the corrugating roll, which if it didn't have that, it would be the end of the roll. It doesn't matter whether it's chrome or stainless, that roll would be done. But by putting these crash rings on there, that will help eliminate the chance of damage. So this has become pretty much a regular thing now that we're doing for all of these OEMs is add these crash rings. So, but I haven't even got to the punchline. because the punchline. Well, let me explain the metering roll.
Okay.
So typically, with the metering roll, is a chrome surface, and you have a scraper blade scraping the excessive starch off the metering roll, and that scraper blade is friction, and normally you get a score line or two, and then almost like a cancer, you'll have hundreds of lines across the face of that roll. And now you're not able to control that gap. You're not able to control that transfer. You want that even, consistent transfer of starch. So again, at this point, the rolls need to be redone. So what we do with these rolls is we'll actually turn off all the chrome, we'll turn off the corrosion barrier, we'll put a stainless steel corrosion barrier down again to prevent any corrosion from happening. We'll then plasma spray ceramic about 10 thousandths per side of the chromium oxide. The porosity is down under 0.5%. The hardness is about 1,400 Vickers. When you compare that to chrome, which is typically about 700 Vickers, we're talking about twice as hard. We have a proprietary finishing process where we hone that surface. When we're done, it almost looks like the back of your black iPhone. It's like a black mirror. And the selling point of this is not only is it much, much harder to prevent those score lines, but it's also much smoother, so that it will potentially extend the scraper blade life by 10 times. But the biggest selling point is the fact that the TIR, or the run out, is, are you ready for this? We shoot for a maximum TIR of 0.0002 to 0.3. That's on both roundness and straightness. So in other words, we've now got a set of rolls where we're able to much more uniformly control the gap. And that's where we talk about the punchline. But again, before I get to that, I just want to make sure that you understand, please, that the durability of this roll compared to the chrome roll is probably 2 to 3 times the life expectancy. With better scraper blade life, easier to keep clean, is less porous. But now, again, getting to the punchline, the fact that we can now control these gaps. In other words, typically, if a roll's out of round, you see this, what we call flashing. Now, because we have so much more control, we can help the box manufacturer close the gap and run a more uniform application of starch. So what we always encourage our customers to do is to retest the board strength. So there's a couple of ways to do that. You've got what we call the iodine test, where they peel the board apart and they put iodine, they can see where the starch is. Or they have what we call a pin test, where the pin test, that you put pressure by pulling, and it's usually one of these two ways that they can test board strength. The last thing they want to do is make weak board. That's why normally they'll increase the gap, but then they pay the price through warp and washboarding. Now we say, okay, please, Mr. Customer, please recheck your gaps. Try closing it a couple thousandths. Retest your board strength, and you might be very pleasantly surprised to see that not only can we make better, less rejectable board, but we can save starch and we can save energy, and we have less rejections. So just to sum it all up, is this technology was developed over in Europe. We've made friends for life. We've now made literally thousands of these glue sets, and we're very, very confident that this technology can help you making better printable board.
Aaron, thank you very much.
Thank you very much. Sorry that was a lot. Speaking very fast.
Yes, it was very interesting.
But
thank you. Have you good, great show, and all success for Apex, and amazing, great company. I see your great history and unbelievable technology.
Well, thank you so much for your time and interest.
Thank you.
Have a great day.